Coming up next, we have Xiao Jianxiong, more affectionately known as Professor X. He is the founder and CEO of AutoX, one of only 3 companies in the world to have been awarded licenses to test the autonomous technologies in the state of California. Perhaps we'll hear from Professor X as to how KITT, the Night Rider car, could become a reality sooner than we realize.
If you see globally, not just in China or in US, but globally, we can see the trend that the technology is getting more and more mature and it's getting ready for massive commercialization. So we should expect that in the following few years, a lot of cars will be turned into self-driving cars. In about 5 to 10 years, there could be more self-driving cars than regular cars.
And of course, when it comes to self-driving cars, your pilot proves otherwise, but people are generally still a bit skeptical about it. They might say self-driving cars work really in only geo-fenced areas. They're not so sure about the safety outside of those areas. What do you say to that?
Yeah, safety is always the priority. The geo-fence area is always make a lot of sense because with a limited geo-fence area, you can do a lot of testing and make sure you have a huge amount of data to support the safety case. But the question is that this is not really the weakness, this is the strength.
Tell us more.
The geo-limited area is actually, geo-fence area is really great actually, because the whole Earth, in some sense, is geo-fence, right? You cannot drive outside the Earth.
Not yet, at least.
Yeah, so it's a matter of how big it is. If the geo-fence area is big enough, is reasonable enough, for example, in Singapore, is the whole city, is the whole country, then nobody will feel that it's geo-fence. If the geo-fence is only like one street, of course, it's very limited, it would not be useful. But if the geo-fence area is the whole city or is the whole country, I don't see people see any limitation. So the so-called geo-fence is more like the technical terms, how we, as the engineer and scientists, approach this problem. But it's actually not a weakness. In some sense, it's actually better because people are very careful. People are very strict on how we make the safety case, using tons of data to put the safety case.
That's an interesting perspective. So in a way, the whole Earth is a massive geo-fence, and the fact that you test with a smaller area is just proof that, eventually when you, first is proof of safety, and it also means that you can just keep expanding the geo-fence. I'm curious, when you expand the geo-fence, right, let's say starting from 100 blocks to the entire country, does that affect the precision and accuracy of your self-driving cars?
It does not affect the procedural accuracy. It's more an economic reason. If you're operating in a bigger geofence area, you need to keep the HD maps updated. That is going to cost money, for example, actual cost. So usually when we choose a geofence area, we're choosing those make a lot of commercial sense. For example, in the downtown CBD area, there are a lot of people doing ride-hailing. So there are a lot of business case to be made. There are a lot of revenue to generate. So therefore, we will start with those more CBD area with a huge demand for ride-hailing. For a lot of countryside or places people seldom go, is economically may not make much sense to do self-driving there. So all the kind of transportation always find that use case. Like for example, even today when we invent cars, people in certain countryside area, they're still riding horses, right? It doesn't mean that when self-driving car comes, that all 100% all the car will be self-driving. Maybe 95, 99% of the car will be self-driving. But certain area, it still make a lot of sense. It's just like people still riding horse, still biking, people still using motorcycles. All different types of transportation means have some use case.
Interesting. So it seems like if you do limit your robo-taxis, for example, for now to a certain geo-fenced area, it's not because of a limitation of your technology, but more kind of what makes sense financially, right? Economically, what makes the most sense. Now, another question I'm sure people have is about another aspect of safety, right? So we have established that you can test in a large area. the other aspect of safety is if you were faced with very complicated driving situations, like the lighting is dim, or somebody suddenly dashes out, or how do you distinguish whether that's a box versus that's a cat versus that's a kid? So false positives, negatives. What do you say to all of that? You know, people's lingering concerns about really how sensitive and reactive your technology really is.
Yeah, this is totally the most important technology problem that we need to solve in order to have the car drive safely on the street. That's why we increase all kinds of sensors. We have cameras, we have many cameras, we have very high resolution cameras, we have high dynamic range camera to deal with different lighting conditions. Like I mentioned, daytime, nighttime, raining days, both China and Singapore rains a lot, right? We have to deal with the extreme weather situation. We have LiDAR, we have high resolution radars as well. We deploy most advanced 4-dimension radar, which is super high resolution radar as well. So all this problem is technically solvable. It's a matter of putting together and then leverage a huge amount of training data with the AI, with the deep learning, machine learning algorithm, leveraging this huge amount of data to drive safer. That's actually the benefit. Again, this is not the weakness. Because human, after a certain level, we learn how to drive, but we cannot keep improving for hundreds of years because none of us really all drive at hundreds of years, right? A computer, they can actually drive at the same time. We have over 100 vehicles driving in many cities in China every day, accumulate a lot of data. And computer, like if I know how to drive, I cannot teach you how to drive. I cannot copy my brain to you, right? But computer can really copy and combine that knowledge. And they are not just testing in the real world, they are testing in the simulator as well. This is what makes it become better and better. There will be no limit how good a computer can drive a car. And very soon you will surpass a human capability and you will become a superhuman. You won't just stop there. You will become a superhuman driving capability.
That is true. You know, sometimes the more we drive, the more tired we get, or sometimes some people sneak alcohol into the system, and in some ways, absolutely, you're right. Your cars could be a lot safer than a human driver. Now, I think at this point, let's take a look at a video. I know you have a video to show us on AutoX. Let's take a look at how it actually works.
Yeah, this is a video just to show that our car is driving on the street and completely driverless. We are the first in Asia, and right now the only company in Asia that managed to achieve that in a street in Asia. So you can see that our car is completely empty. There's no one sitting in the driver's seat. There's no one sitting in the first or second or third row. You can use it for ride hailing, or you can use it to move your dogs, or even moving logistic moving boxes and so on. So there are tons of applications for this. This is just a video to demonstrating that our car is driving completely on the street. A lot of people feel that a self-driving car is still quite far from our daily life, but a lot of new technology is always like this. A lot of people feel that cell phone is very far from our daily life, and overnight you realize everyone has a smartphone. The change of technology is always coming very quickly. And we have this self-driving car you can see on the screen. This one is Chrysler Pacifica vehicle. We are partner with FCA. This is a special vehicle designed from the very beginning to be suitable for self-driving. It has all the redundancy drive-by-wire system. You can drive in daytime and nighttime, as you can see here. You have all kinds of sensors, including LiDAR, camera, radar. This is equipped with our fixed generation system with all the sensors, including the blind spot perception capability to recognize very small objects. Like you mentioned, like cats, dogs, running on the streets. We can do this. We are operating a fleet in the city of Shenzhen right now, allowing people to try completely driverless.
Yeah, how has that been? I know you launched that in January, right? When you opened it to the public in Shenzhen. How has the feedback and response been to that?
Yeah, it has been wonderful. A lot of people already it's very welcoming by the citizens. in Shenzhen, as well as by the government officials as well. There are many government officials nearby Shenzhen or even far away in the country. They fly all the way to Shenzhen just to experience. Because people keep talking about self-driving car, right? Very few people, put it this way, very few people have been sitting in a completely self-driving car. You have the car completely empty, just yourself sitting there. It's actually seeing is believing. So that's why they fly all the way to even to try it.
To Shenzhen to try it for now. Sitting is believing. Curious, I'm sure some people are wondering what are the economics of this? How much did that ride cost compared to an equivalent common Grab or taxi ride or Didi Choosing ride?
Yeah, in China, the actual cost, because of the computer driver, is almost the same with a typical human driver salary, a full-time driver salary in China. So it depends on which country. For example, in Singapore, the driver actually costs a lot higher than in China. So if you count the unit economic in Singapore, it will be make a lot of sense. In China, right now, it's pretty much the same. But self-driving car is a scale economic because right now we only have over 100 self-driving cars. We're not having tens of thousands of self-driving cars yet. So that's why it's expensive. Once we are able to scale it up, the price will drop dramatically. The industry predicts that by 2025, each self-driving car on top of the vehicle will only cost $5,000 extra to get the car fully self-driving.
Wow. So it really sounds like as technology matures, of course, the base cost of technology decreases. And especially in high labor cost societies like Singapore, really, your rides are going to be a lot cheaper than other traditional rides out there. Now,
yeah, it's not just cheaper, but also safer as well.
And safe.
Safer in terms of traffic accident, in
That's
terms of in the light of COVID-19, there's no one sitting in the car. It's much safer in terms of health. And also no conflict between the driver and passenger. So it's actually safe in that aspect as well.
That's true. Safety on the road, safe in terms of hygiene and of course being economically viable too. Now imagine you said this world, imagine if now 80%, if not all of our cars are self-driving. How is this going to fundamentally change the way we live our lives? How is it going to change the way cities operate even?
Yeah, that's a great question. A lot of cities are going to be, first of all, expand the size. Because now you can do mobility very easily. You can sit in the car. You can just call a car. You don't even need to think about the car. And then you just move from point A to point B. Suddenly, you free up a lot of time in the vehicle. That's make everything more, it's not teleporting, but it's close to that. So the size of the city will expand, and the downtown will be actually probably bigger, or even there's very few weaker concept of the downtown. So we see that people also may stop buying more vehicles. Some people may still buy cars. Some people may stop buying cars because calling a robot taxi is much easier. That's why we also see that in the automobile industry, there will be also a huge disruption into the next stage. People will care less about the car, but care more and more about safety and more about mobility instead, which brand is the car, but they just want to get a car that is very safe.
Wow, I think I have some related questions here, so I'm going to jump straight to Q&A. Ray says, asks you, when do you think robo-taxis or robo-buses will become a common sight on city streets? In Shenzhen, Singapore, carrying passengers for a fare. And a related question is maybe besides carrying passengers, carrying goods, right, as well. When do you think that scalable side is going to be possible?
In China, it's happening, as we mentioned, that Shenzhen, that January this year, we already start from 0 to 1. Now the next is from 1 to 10,000. So it's starting already.
Where next?
That's mostly for robot taxi. For robot trucks and for robot buses, it's going to come much later. Because robot taxi has a lot of benefit. One thing is the unit economic I mentioned. One taxi driver have to drive to move one person. That's 1 versus 1. But in the robot bus case, one driver, you can actually move 40, or in China, some bus have 100 people sitting inside. So the unit economic may not make much sense, right? Because the one driver salary will be amortized with 100 passengers. The other one is really like you mentioned about safety. A bus is much bigger, that make it harder to drive. A taxi is smaller, actually make it easier to drive, make it safer to drive. The other thing is also a lot of people, in particular in China, I'm not sure about Singapore, when you sit in the bus, people don't fasten their seatbelt. There's no seatbelt. So it's actually more dangerous to sit in the bus, assuming the technology equipped, the difficulty of the level of safety is the same, but sitting in the bus will still be more dangerous. That's why bus will be actually come much later.
Right.
For goods delivery, it's true that it's, of course, because there's no passenger there, it's an interesting area. But in goods delivery, because the automobile industry is much less mature in terms of the drive-by-wire system, underneath the electronic of the car is less mature. So it's going to take longer time, probably take a few more years in order for the whole industry, for trucking, to upgrade the reliable control of the system first before they are driverless ready. So we expect that robot taxi coming very soon. Robot truck will come slightly later, and robot bus will come even later. For robot taxi is happening in China. We hope that it will be happening in Singapore very soon as well.
Well, we look forward to that. So really kind of expanding your current robotaxis for the car sector, then trucks when the technology matures, and of course, finally for buses on the commercial side. Interesting. Now, more questions. You have some fans or followers from Russia. What perspectives do you see from Russia in the development for unmanned vehicle technology? They also ask, are you considering the Russian market to expand your presence there?
Yeah, we're definitely interested for the global market. Like that way, at the moment, we are more focused on the China market. And then our next step will be on the Southeast Asia, like Singapore. But after that, we will consider expanding to other areas as well.
Right, so the short answer is yes, but perhaps after China, Southeast Asia, then finally. Finally, we'll get there. Right, and lastly, a technical question from David. Most navigation and computer algorithms, or vision algorithms, rely on non-deterministic approaches. How can we prove to authorities that our techniques will always work in a deterministic way?
It's actually, I disagree. Most technology work on a deterministic way. For example, even if you have a neural network system, after the neural network system is trained, all the numbers, all the parameters in the neural network model, they are fixed. When you do the inference, it's fully deterministic. There's no undeterministic. During the training time, there could be stochastic gradient descent to make non-deterministic. But when the model is trained, when it's finished, when we deploy to the car, everything becomes fully deterministic now. That's why if there are any problem, we can actually pinpoint which component of the system has the problem. We can even pinpoint up to which line of the code, or which model, which number, which parameter has the problem. This is actually the beauty of robotaxi, because we have the black box to record all the data, and we can deploy the data to reproduce exactly what's going on, and to pinpoint the problem for every single traffic accident.
So in short, not to worry, the technology is deterministic once you cross that particular stage. So in fact, like you say, it's a lot safer for everyone in all ways. Well, with that, thank you so much, Professor X and Xian Xiong. We look very much forward to having robotaxis in Singapore and eventually trucks and lorries and buses as well. Thank you so much.